Okay, so what we're going to try to do here is to show you how to analyze the frequency of these spikes, and we call extracellular recordings of action potential spikes. So these are recordings from the third root with the suction electrode, and let's just look over the file. Remember, you can pull your file up, and if you're already familiar a little bit with chart, let me just go through a few features that makes it easier to look at your file. Remember, you can spread it out by this little click down here, this little mountain, or you can condense it up by clicking that way. Let's look over our protocol real fast with a kind of a condensed version of the file. So what we did is to record from this third root with the suction electrode and then brushed on it 5 or so times during saline. So here is brush 1, it's called saline 1. So in the saline we brushed on it, you can see the activity. And we did it again, and again, and again, and again, with a little break in between. So here are 5 brushes. What we're going to do is to measure the frequency of activity in each one of these runs, and then average that activity, because there's some variation with each of the brushes. So this will help us get an average value for the brushing. And then you see there's some baseline activity. Notice the baseline here wiggles up and down, and then you have spike activity on top of that. This wiggling up and down can't really be avoided in these animals too easily, because the whole abdomen's in the dish and the little swimmerets are still moving around, or the animal can kind of move its abdomen a little bit even though it's cut away from the thorax. And so there's movements in the animal, like those swimmerets moving, that causes the saline to move around, and that causes these deflections in the recording. Alright, so we do saline first, and then we go ahead and you'll see on a file, it probably will say something like add LPS or add whatever concentration of LPS. In these files, the first ones we're doing, the name of the file has 500 in it. That means it's 500 micrograms per mil of LPS in the crayfish saline. And then we might have some kind of noise going on, because when we're adding it, there's noise, or it might be stopped and started after we finish the adding. So here we see adding's done, and then we go ahead and do the 5 stimulations again. So 1, 2, 3, 4, 5. And then we waited 10 minutes with the LPS sitting in the bath, and we swished it around before letting it sit. And then we did 5 more runs, and so you see 5 more. 1, 2, 3, 4, 5. And sometimes there might be extra little markers here with a comment. You can click on it. It will tell you what that marker is, or if you need to edit, you can always go to the edit comment. I'm not sure in the software that you have if you have that ability to see these or to edit, but do they see the marks?
They don't even see the comments.
Okay.
This video will help.
So you might not see the comments in your software. I think there might be a version where you can add the comments in. If you go up here under Windows and you click on comments, you might see the comments here under the window. So let's see if those appear on the software you're using or not. Okay, if you don't see these comments, it might be a little difficult to analyze. Let's address that if you don't have them, and maybe we have to send the time points with when we added or when we stretched, or when we might have to send the time points when we brushed on the side of the animal for your measurements, because what we're going to do later is to measure the frequency over a set period of time, probably 2 seconds. Anyway, so here's the LPS that's sitting on for 10 minutes, and then we have another time point of 20 minutes with LPS, and you can see 1, 2, 3, 4, 5, and then there's some background activity that's going on, because as Krista mentioned earlier, there is this background activity that's just spontaneous in this preparation. And then we washed it out, changed the saline bath, and usually change the saline 3 times in the dish to try to get all the LPS out. So this is why it says 3 times. Sometimes we don't write the 3 times, but we changed it out 3 times. And now we're brushing again on the side of the animal. So here's 1, 2, 3, 4, 5, and look, it's not as active the fifth time than it was the first time. So we want you to record the numbers in case we want to plot it 1 through 5, but for some of the analysis we might just average the overall activity. So anyways, we'll collect all the data and have it in a sheet, spreadsheet. And then we wash it again after 10 minutes, letting it, switching out the saline again and flushing it out over the ventral nerve cord. And here's a nice recording of 1, 2, 3, 4, 5. And then we let it sit again, but here it says another 10 minutes. So a total, and it's washed again. So the saline's actually changed out again. Here it's changed out, and we got rid of the little air bubble that was inside of the electrode. This is all that noise. And now we see here are the last 5 runs. 1, 2, 3, 4, 5. And some of the files will show this part over here. I'm going to extend this out so you can see it. They'll have this calibration. So with our P15 grass amplifier, we push this little button, and it gives us 100 microvolts calibration pulses. So from the peak to the base, that's 100 microvolts. And so we can calibrate the size of these signals as well as our noise. All right, to analyze the data, what we need to do is to try to count these spikes. And as you see right there, you can't count them, so we have to spread it out a little bit. All right, so we're spreading it out. And let's go to that first one. There's number 1, there's number 2. Something that might help you, let's condense this, I'll show you what might help. You can see that where you zoomed in, like from that little mountain, it might zoom in the center of what you're looking at. But if you click right here with your mouse, you click, and then you zoom in, then you zoom in, it should have gone right where you had your click, but it didn't. All right, anyways. Cut that part. Okay. So what we do here is we need another channel. So what we're going to do is to open up the setup up here in channel settings and write number 2, and then you have 2 channels, and you're going to see 2 channels here. This second channel you don't need to have so large, so what you can do is grab it in the center, pull it down like that, and you can also enlarge your signals that you have here by stretching out the y-axis. Might help you a little bit. That way you can see these, and you can still stretch it out a little bit more. And you see there's some 60 cycle noise that a little bit, but these are spikes right here, and these are bigger spikes. You get different size spikes because there's different size axons in your extracellular recording. The larger axons get rise to larger spikes. The smaller axons, smaller spikes. All right. So now we have this one in the center, and we want to count the frequency of these. Now you could zoom in for like 2 seconds and use the windows up there and actually try to manually count these, which would take a long time. But let's go ahead and see if we can do this with an automated approach. So what you do is you go to channel 2 down here and you hit cycle measurements. This window will open up, and it can be a little confusing at first, but what we want to do is to make sure that we're looking at channel 1, and what do we want to measure? We just want the number of events so we can calculate our own frequency. So what we're going to do is just put it on count, and then down here you see these 2 traces. The black bar gives us a standard deviation of our trace, and you can see what it's counting. There's little circles up here at the top. That means it's counting those spikes. But look, we're missing that one, we're missing that one, we're missing these and here. And this is because the baseline's moving up and down. The best approach to look at this is going to try to measure any events that are greater than the standard deviation of whatever the file is that you're looking at. So we want a sine wave analysis, so it will follow the recordings, not just a straight line across there, but it will follow the baseline shifts that are happening. And then you can get rid of the black line if you want by clicking right here, this part. So you can either click on it, and it'll show you that, or click off, and we can take it off. And now we want to zoom into this area to make sure that we're counting what we want. So We can even zoom in through here and kind of look at this file. You can also extend this out if you want by stretching it here. Let's zoom in a little bit more, because what we want to show you is how we're going to count this. And every one of these little circles it's going to count. But look we missed this one, and we know that's an event. And it's not counting this one, and we know that's an event. So what can we do? We can take the standard deviation here and we can lower it. So now, if we keep lowering this, we will see in time, oh, it grabbed that one now. That one's counting. And it grabbed this one. It's counting that one. Let's go a little lower. And if we go here, now we're counting this one. So now we're pretty convinced it's not counting, little noise values, but it's really counting the spikes. And to double check it, you can extend this out and scroll through your trace. So here's 2, here's 2, here's 1, and you see it's counting everything that we want in this trace. So I don't think we're picking up any spurless activity. We're really getting just the events that we want. We can also copy this standard deviation because we want to report that with our analysis. So let's just say OK here. You can even copy and do a Control-C and copy that value for putting it on your spreadsheet later. So now we want to count over a certain period of time. Let's say it takes us really about 2 seconds to make the brushing on the side of the cuticle, because we brush down one way with the manipulator and then we brush back to the starting spot. So it's like 1/1000, 2/1000. So if we are consistent in our analysis, then let's try a 2-second analysis. So we go down here to the bottom left corner, we drag that little marker, and we can put it right here. So at the beginning of this, even though we had saline, we said we started the brushing, but we know it probably didn't start right there. That's just when we hit the button. So let's start at the beginning where we see this really nice sharp increase in the frequency. So if we go from there, and now that we use the marker, anytime we move the cursor over here, you will see up here in the right top corner a delta. When it's a delta, at the very top you see it says up here where it says 20 kilohertz per second, that was our acquisition rate. But when I move this cursor over, now you see the time. And it's wherever the cursor is. So if I go to the end of this black line example, it's only 2 and 19 seconds. So if I start here at the beginning, there's, almost 0, right? Good enough for government work. Maybe I shouldn't say that. Let's see, if I move that over, we might be able to get it right on 0. If I spread it out a little bit, it'll help more to get it more accurate. But good gun. Okay, I won't say that. Okay, so let's just move that right there. And like right there, there's 0. And now if we go over from here where it starts at 0 and we highlight that out to 2 seconds, getting it close enough for analysis, there's 2 seconds pretty much. Well, okay, and you might count that. We know we might be off at 1 count or something. This is why we average as well. But anyways, now you see that black spot. If you hit the zoom, it will zoom into that spot that you just hit. If you go back to the chart view, then it goes back to this. So this is our analysis, and we saw that when we did the when we did this cycle variables, for example, we see that it's counting those values throughout there, and we can zoom in again, and you can see where you were. Where was this? Oh, just to show you example again, the timing in here can be a little bit off. You see that we're really at 13 and 12.5, so you can move this down to 12.5. It takes some time. If you crunch it up, it'll go faster. I'll have to make some cuts in here. Here we go. Here's the 12.5 where we started the file. And now you can kind of see what's going on there. If you want to spread it out, you can make sure again that you're making sure that you record everything. If we went this way, you could see that we've got all the events that we want. Okay, and that's our standard deviation. So I'm going to copy that because we're going to use that in a minute. I'm going to say OK. And now what we can do is where our marker is, we can move this back up here and say begin at the beginning. And you'll see that over here to your far right, it's going to actually take a count wherever the cursor is. So we're starting at the beginning of this 2-second run. Remember, look up here, where you blackened it out, you know where the end of 2 seconds is, about right there, somewhere close to it, right there, right? So now you see that there's 105. It's really 105 down here. When I go to 2 seconds, that's up here. I go to 2 seconds about, there's 105. So that means from the marker to this value, we have 105 spikes. Okay, we can remember that, right? Let's go to an Excel file now. Let's open an Excel file, and you can make your Excel file the way you want, or maybe the same approach is a good idea. Saline, we usually do 5 runs. Sometimes it might be 6, so you might want to put a 6 in there. Then we did the LPS right away, then LPS 10 minutes, and then we did the 5 runs again, right? So 1, 2, 3, 4, 5, and then we did an LPS 20 minutes, right? And then we can do 5 again, but you get the idea. So right now we just did the first out of the 5 in saline. I tell you what, let's make sure that we mark this column as a standard deviation. And remember, we copied that, so now we can paste it. That was our standard deviation that we used for count 1. And we had 105 spikes. And we can say this was good. It wasn't too noisy. And now we can do the number 2. Let's put that down. And let's move over to the second one. Let's just do 2 as an example. So here's 2 right here. And if you click back over here, the little marker appears back over here in the bottom left corner. And let's put that up there. And let's see how far we're going to go. We're going to go all the way over here. Let's stretch this out a little bit then so we have it on our same window. There would be 2 seconds about right there. We know there's no other spikes, so we don't have to be too worried about getting out there. You could either highlight it again if you want to. Close enough, and go to 2 seconds, or what is going to be accurate enough right there. Then we can go back over here and click our M. Notice the trace disappeared here, and it's because it went off the chart. So you can just click over here and, whoops, I clicked too much. You click here and you do auto scale. Auto scale will pull it back in so you can see it. Remember, it's counting from the beginning of the file, so these numbers get larger. This is why you have to do a change. So we use the marker here, and now we're going to move over to the 2 seconds. And we know that that's close enough because we're not having any other events. And we know that's 120 points over the 2 seconds. So now we can put that back in here, 120. Let's see if we're missing anything, and maybe the standard deviation's changed on the analysis. Maybe the noise has changed. So let's go back over there real quick and just check it out. And if we do this, and we do that, and we want it around 22, so it's close to where we are right now. And it's a little bit over here. This is this area. We're not getting anything in the noise. We can spread it out a little bit more. Are we missing anything? Are we getting too much? Let's look what we're doing here. And so it looks like it's getting everything that we would want. It's not picking up any crazy noise, so this value is pretty good to use again. But I think you really need to check that each time, and otherwise it could be a problem. So what we can do is, since that stayed the same, we'll just put it there. And this seemed to be pretty good, right? So we go on through this, and we'll get all these counts in an Excel sheet. Later we can take these and average them for saline, LPS initial, LPS later. We can also plot each one individually and see if there's a change over time of stimulating. Some drugs will block activity that are use dependent, like an open channel blocker, so it might block it more over repetitive uses. So it could be interesting to see if there's a change on each of the trials. So remember to save that file, name it something, maybe save often so it doesn't get deleted. And when you're finished with your file, if you want to, if you had to take a break, I think you can save your files on the chart reader that you're using. If not, you might want to make a mark on your notebook or something. One other thing to watch out for when you're zooming in, on some of these files, I'm going to crunch it up to show you the point that I'm going to make. We just did saline, and if we start and restart the computer, as you see here, I think it happened. What? No, it didn't do it here. This is 25. I'm looking at the count, the time down below. It's all going okay, and then we added LPS. But right here's the point. When we stop the file and let it sit for 10 minutes and we restart it, you see the timing starts over again. So when you zoom in, when you're doing your analysis down here, you have to watch out that what frame are you in. So that says 15 and 20, and it's right here where we are in this file. But if I went way back over here, there's 15 and 20 again, but we know that's the saline. So watch out for when you're doing your analysis. I think if you click, let me get rid of this. I think if you click here, let's try it. If we click here and then go to cycle measurements, it pops up where you just clicked, and then you can expand this. And so this is the right time point for what we just looked at. Okay, that could be the only confusing part. And then we'll count this, put that in the Excel sheet. If you have any questions, just email us. And at the end of this video are some references about the preparation and what people have done in the past with some of the analysis. You can see ways to graph this. We welcome discussion on this.